Welcome back to Built to Ship, the podcast where we go behind the scenes with founders and product leaders shipping real AI products into the world. I'm your host, Tyler Postal from Voker, and today I'm really excited to be joined by Quinn, co-founder of Daily, the real-time video and audio API that powers everything from telehealth to AI, voice and video agents, and also the team behind Pipecat, one of the most widely used frameworks for building voice agents for things like customer support. Quinn, it's great to have you here.
Thanks for having me. It's great to be here.
Amazing. Well, I know you have a ton of experience in the space, and lots of folks probably already have heard of PipeCat and Daily. So I bet you have an interesting story to tell. Can you tell us a bit about what you were doing before Daily, before PipeCat, and how it all led you here to this idea and these amazing products you've built?
So, a really long time ago in grad school, I fell down the network engineering rabbit hole. I got really, really interested in building the very large network scale, low latency, flexible, programmable systems. Audio and video, real time audio and video is sort of part of that whole way of thinking about how do you build large scale network systems. So I've done a series of companies around large scale networking stuff, real time audio, video, communication, collaboration. My company before this, I co-founded with a friend from grad school. We were the folks. He was the guy who did the gestural interfaces in the film Minority Report. So we built these room-sized
Whoa.
systems you could walk into, and there were screens on every wall, and you could control them with your hands. That was a really, really fun, uh, you know, engineering project that we managed to turn into a company. When we exited that company, I took a couple of years off and still wanted to build these networked, collaborative, real-time audio and video systems. And there was this protocol called WebRTC that was just starting to become a standard. This was like 2015, 2016. And I thought we could build a company around the goal of designing the world's best global infrastructure for developers for real-time audio and video, because I thought there was just going to be more and more meetings like this. You and I aren't in the same place, but we're talking,
Totally.
and it's amazing. It unlocks all sorts of stuff. And that was the genesis of Daily, was betting on WebRTC, betting on the growth of kind of real-time communication and building great global developer infrastructure for that. So now, as you said, we have customers that run, some of the world's largest healthcare companies run their telehealth on us. Some of the world's largest podcasting companies run their podcast recording infrastructure on us, and many, many other really interesting human to human use cases. What's happened in the last couple of years is, as with everybody else's companies, everything has changed. And now our infrastructure is used for human to AI communication just as much as for human to human communication. And I think over the next few years, we'll have 1,000x more human to AI minutes than we do human to human minutes. And we sort of saw that coming right when GPT-4 launched. So we built this open source framework. Well, first we just started experimenting internally, right? We built all these tools to figure out, okay, what does it mean to like talk to an LLM? Like, obviously you can type at it. Can you use your voice? How do you do that? What are the tools you need? What are the challenges? What are the problems? So we built a bunch of stuff we got really excited about. And we thought, okay, this is super early. The best thing we could do is just open source all this stuff. So we open source all the tools we'd built internally for talking to an LLM. And that became this project called Pipecat, which is now vendor neutral, used by all the foundation labs, all the hyperscalers, lots and lots and lots of startups, scale ups, enterprises. I meet somebody every day who's using Pipecat who doesn't use any of the daily commercial infrastructure, which is like really great. It means an open source project should really hit that tipping point. And so now I spend like 80% of my time on the open source side, just because there's so much interesting stuff to do there. So that's my backstory and the company Daily and the open source project Pipecat.
Amazing. I mean, you've been through probably all sorts of interesting waves of tech. You mentioned all the way from the Minority Report days to today. What's like the most thing that's exciting about the time we're in right now? And is there a time that you actually like kind of miss? In all of your journey of founding companies and building products, what's been your favorite time?
Oh man, it is hard to beat right now, but partly that's so I'm thinking a lot about when I was a baby programmer and just starting out, and I had discovered the internet and thought, "Oh my goodness, this sort of global connectivity thing is wild. I want to figure out how this works," which is how I kind of backed my way into computer science grad school, even though I wasn't a computer science undergrad. And everything was new when the internet was new. like how we built software was changing, how we thought about what software could do was changing, and how we distributed software so people could actually use it was changing. And I remember being, 19 years old and not knowing anything and being convinced that this was like the revolution, the future. And people who were like 15 years older than me were like, yeah, but like we already know how to write software and yeah, it'll change, but like not everything will change. And it turned out both perspectives are right, right? Everything changed, but also that like full stack engineering perspective that people who had like really learned how to write good computer code, had learned over their careers was also still super valuable and remains super valuable. But the exciting thing for me as like a very early career engineer was like all of this stuff seemed like it was coming at us so fast. And I have not felt that way quite. I mean, I've loved being a computer programmer for 30 years, but I've not felt quite that way until, the last year or so. And so it's like 19-year-old me and, however old I am now, me are almost the same person because everything is changing again. How we write software, what software can do, and how we distribute software is just going to totally, totally change over the next couple of years. That is so much fun.
Yeah, it's very exciting. And while I can't claim to have seen like the advent of the internet, I definitely, saw some of the early days. And I'm curious, like, it is amazing everything that's happening now, but I still like wonder, before the internet existed or in the really early days of the internet, wasn't that extremely, kind of exciting and probably, I wonder almost, did that feel almost more, like, powerful of a new technology. Now that we have the internet, it's like, okay, it is crazy that LLMs can do all this stuff, but like we've seen what the internet can do, we've seen what computers can do. I'm a little less surprised. Or do you still think that like this is even more impressive than the early days of computers and the internet?
Well, one way, I mean, I don't think there's a right or wrong answer there, right? Like it's in the eye of the beholder. But one way to think about it is that every time we build another layer of technology, we expand kind of globally what computers can do, and we can do even more. So like the transition to the PC where everybody could have a computer in their office and at home, that was genuinely exciting. It felt to me, at least, like the internet was even more exciting because connecting the whole world was amazing. Putting an incredibly powerful supercomputer, the iPhone or Android phone in everybody's pocket, genuinely exciting. In some ways unlocks even more potential. You couldn't do that before you had kind of the layer of the PC, the layer of the internet, then the smartphone. Um, so in some ways, LLMs get, they're standing on the shoulders of giants, right? You can do even more. Um, and I think it's hard to argue with that. I also think you could make the argument that the step function change that LLMs make possible is just by itself even more amazing, because computers have always been structured data machines, and now
Mm.
computers are natural language machines, and that is truly amazing and takes us at like a massive step towards being more human like, whatever you mean by that. And I am thinking about that every day because I'm trying to rewire my brain so that the things I do with a computer, like the code I write or the code I have coding agents write, is AI native in the sense that it's natural language code. And I think it's going to take all of us 5 years to figure out what that really means. It's so, so big. I did a I did an internal talk for people at Daily in 2023 after GPT-4 came out because it was clear at that moment, like the GPT-4 moment, I thought was a really big moment. It was clear that LLMs were going to be really, really, really important. But I mean, so hard to sort of see around corners, right? So my one of my slides in that internal talk said, this is somewhere between the relational database and the internet in
Mm.
importance. And I think I probably undercounted it. I think it's somewhere between
Wow.
the internet and whatever,
Beyond,
I
yeah.
don't know what the right the printing press or fire or
Mhm.
whatever.
Amazing. Well, I want to give the audience a bit more perspective. If they don't know, tell us a bit more about like what Daily does, what Pipecat does. Is it infrastructure for agents? Is it inference? Give folks a bit more background there.
Yeah, no, it's a great question. So Daily, the commercial company, is an infrastructure company for building real-time applications. So we move audio and video bytes around the network in a super, super low latency, super scalable way. Um, On top of that, we have a variety of things that help developers kind of build those real-time applications, including agent hosting. So you can kind of Docker push an AI agent to our global infrastructure if you have like an inbound customer support use case where you're answering the phone, for a small business, or answering the phone for like a healthcare practice as like a receptionist, a virtual receptionist front desk. We have lots and lots and lots of customers building these like voice agent use cases. All of the kind of next generation real time video avatar companies also either build on our infrastructure or use Pipecast or both. And we're starting to experiment. Well, I'm sure we'll talk about this later with what like larger applications that are fundamentally sort of real time, voice driven, collaborative are starting to look like in this AI era.
Amazing. A lot of people have experimented with like text-based LLMs. I think voice is a bit more complex. There's different architectures you can approach. Like, I hear a lot about speech to text to speech or just direct voice to voice models. Can you give a brief overview around where you'd say the industry's at? Is there just one architecture that makes the most sense? Or are there reasons to use one versus the other? You've mentioned latency a lot, and that's everything I hear from people building voice agents is that's such a key challenge, because with like a text agent, you're used to someone typing back to you in customer support and like seeing those little bubbles of like the person's typing. But with voice, you want it to feel natural.
Yeah, I'm the person that, you always roll your eyes because I'm talking about latency all the time. Because as you said, any kind of real time conversational application where it's voice, that how fast the agent responds is so important to the end user experience. We want, when I stop talking, that voice agent's response to hit my ears like in less than a second and a half, ideally even quite a bit faster than that. And we're so hardwired as humans to expect these pretty fast conversational responses that if your voice agents don't respond quickly, people just will not tolerate it. And that latency builds up at every layer of the system, every part of the processing that goes into building a voice agent, which takes us back to that architecture question you were talking about. The production voice agents that are deployed today are almost all using three different models that stream data between them as fast as possible. A transcription model that turns the user's voice input into text, an LLM in text mode that takes that text from the transcription model and outputs a text response, and then a voice generation model that takes that text and turns that text into a voice response that the user hears. And the reason we're using those three different models is because you can get higher performance from specialized models today than from like one big model that tries to do it all at once. And that's really important because voice agent use cases are typically very, very demanding in terms of like the intelligence quotient you require from them. You need really good instruction following. Almost all production voice agents use tool calling really heavily. So you need really good tool calling. And then it turns out that today's LLMs are good but not great at long multi-turn. And if you think about, we all use like ChatGPT and Claude all the time now. A typical conversation length is probably 5 or 6 or 7, like back and forths. And a really long conversation, probably 15 or 20. Well, a typical voice conversation is like 30 turns. And a long voice conversation is like 100, 120, 150 turns. And so we're just sort of pushing on the boundaries of what these LLMs are good at. So we need to use the very best LLMs. There is a new architecture that, we're experimenting with, that the labs are working on, that I think we will over time start to move to. That's the speech to speech models you were talking about. That's one omnimodal LLM. They can take audio in and do the intelligence part and produce audio out. Those models are still a work in progress from the perspective of instruction following and tool calling accuracy. So we're mostly not using them in production. But one of the things we're starting to do, and I think this is a theme with a lot of agents in 2026, we're starting to use less intelligent models for the voice loop and making sure that we never block that voice loop. It's always the conversational part of the agent is always available. And then we're using in parallel slower models in thinking mode or specialized fine-tuned models on proprietary data sets or a whole mixture of models that are good at different things that collaborate with that fast voice loop. But that opens up opportunities for all kinds of new like architectural approaches, but we're also all still figuring out how to build those multi LLM systems.
To the point of it being a really exciting time, like these are the things that are interesting to me that I love hearing about, and appreciate you sharing these like insights, because I think a lot back to like the really early days of, let's just say the world like, learning about GPT-4, and everyone's talking about the prompt engineer and all you have to do is get better at prompting. It's like, and I think people are finally realizing, no, it's a bit broader. You need good infrastructure for latency. You need different methods, whether it's a high intelligence model or a lower intelligence model. And depending on your use case, you can design and architect systems, whether that's the infra, whether that's the model you're using. And it looks a lot like, to me, and I'm curious if you agree, like traditional engineering, but just with a specialty. It's not just like, just write a prompt and it works. You need to consider things like infra, latency, all of the quote unquote boring things that maybe isn't as sexy as just saying like, just write a better prompt.
A good user experience is still a full stack engineering effort. And you can't outsource that to like an API that somebody else is hosting. You have to think about it, as you're saying, as a full application you're developing, and infrastructure matters, and which tools you choose and how you wire them together matters. And then evaluation and testing and observability really, really, really matter. I I have this experience where, because Pipecat sort of just kind of blew up early, I've gotten to work with kind of everybody, training models and building specialized tools, and building all of the things that we all sort of need to build these production systems. And early on, the people building these amazing models at the foundation labs had this very, very strong perspective that they were just going to build an amazing, huge model, and it was going to do everything, and we were just going to call those APIs.
Hmm.
And I was always like, well, maybe, but I mean, I've got a lot of experience writing code, and through every era, everything has felt like a systems engineering problem, even as we get better tools. And maybe these new tools are like so much better that that won't be true, but I'm a little skeptical. And it's certainly not true now. Like, it's certainly
Yeah.
not going to be true for a while, because I can see the jagged edges of what these LLMs can do. And even if we push the frontier forward massively, the edges are still jagged of like the frontier of what these models can do. So 2, 3, 4 years, however long we can see in the future, it's still going to be a systems engineering problem, whatever it looks like in 10 years. And I really think that the Foundation Labs people have sort of adjusted their perspective and are now all in on the systems engineering part of it, as well as on the incredible model training part of it. And you can see that because like all of the APIs now are actually full stack systems, right? There
Hmm.
are routers, and there's this global distribution of where you're doing the inference. There's all this super complicated stuff behind those APIs, and that is a systems engineering challenge. And then when we use those APIs, we build our own systems that try to maximize what we actually want these things to be able to do to our end users. And you can never get away from like the systems engineering parts of it and the domain specific parts. Like, polishing an experience for a particular cohort of users is never not important.
Totally. And maybe with that, let's get into like a specific use case that we could talk about. I know you mentioned earlier, the challenge with like long running conversations, and the fact that you guys have done a lot of like dog fooding of using your own product and building things. Maybe share a bit about your experiences there, so that people don't have to like suffer through or learn through the same challenges that you guys have as you've built complex, long running voice agents.
Well, one of the really interesting things about the voice agents space was we encountered a bunch of these problems really early. We always had to be multi-model because initially there were no speech-to-speech models, and now there are. But we just talked about how like we use them sometimes, but we mostly don't use them yet. So we always had these challenges of sort of figuring out how to use multiple AI models together really effectively. And you see in the rise of coding agents and other interesting agent use cases in 2026, everybody's now trying to figure out how to use multiple AI models of different kinds together well. Latency really matters, so we had to sort of tune a bunch of stuff really, really precisely. We didn't have any margin for error. I was with some folks from AWS talking to a big, 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 big company about their agent experiences a couple months ago, and I was asking about their plans to take their text bot customer support agent and add voice capabilities. And they were like, yeah, I think latency is going to be a challenge. And I was like, I'm so glad you know that already. I don't have to give you my like speech about latency. And they were like, yeah, the typical response time right now in our POC is 43 seconds. And I was
Wow.
like, whoa, wait, that's actually not even okay for a text agent, right?
Yeah.
So we're all still like working through the challenges, and the reason was they had all these guardrails, and that's a totally legitimate reason, right? They're in a regulated industry, very large company with, big surface area of regulatory and compliance and security and safety stuff. So they're taking the user input and they're running it through all these guardrails. And then they're running, the kind of main LLM with RAG and the other things you build to like make it domain specific. And then they're running the LLM response through all these guardrails. And if you do that serially, that really adds up. Well, our perspective from the voice agent world is you can do a lot of stuff in parallel. You have to be super careful about it and you have to have good like developer tooling and building blocks for it. But we do a lot of guardrail stuff in voice agents where you have that main voice loop. In parallel, you're doing your compliance stuff. Because you've measured all the timings really well, that your voice loop is usually not even gonna get the first bytes of audio out before your compliance loop is done.
Hmm.
And at worst, it's gonna be 2 or 3 words in before you have to cut it off and steer it if you trigger one of your, guardrails. And that actually empirically is totally fine. And that's how, that kind of parallelizing things is how you achieve systems that work well in the very, very tough domain of voice. Well, you can take that lesson, you can apply it to any kind of agent. The fact that parallelizing stuff is valuable is like a computer science like
Yep.
101, both insight but also a challenge. You have to have good building blocks for it. And I love Claude Code. I spend hours and hours a day in Claude Code. The first time I used Claude Code, like last April, and it said compacting and I couldn't type at it, I was like,
Hmm.
"Wait, what?
Hmm.
Why weren't you compacting the whole time?" I've been building voice agents for 2 years where I compact the conversation all the way along. Like, I I figured that out. Why did Claude Code ship without that? But the answer is they were solving a different set of problems and then wrapping back around to these problems that are sort of common for these different kinds of agents.
Very interesting. Well, I know you guys have applied some of these learnings and tested these things out directly. Recently, you launched Gradient Bang. You want to tell us a little bit about that? Sounds like an interesting project.
So today we launched a game, which is totally, out of left field and not what we do commercially. Although some of our customers build games, but like I don't build games for a living. But I had this like side project thing that was kind of in my brain that, sometimes you just have to write a little bit of code to get like this thing out of your brain so you can do other stuff. And the idea was like I remember these games from, the 90s that were like very simple PC or bulletin board system games, where you had a terminal and you're typing commands and it was like a choose your own adventure type thing. And they were social. The early bulletin board system games were social. And they were so compelling because the kind of gameplay mechanics were simple but really, really interesting. And then if you added the social layer, that was a whole nother thing with sort of the very early internet. And I was like, what if we live in a like a 2 world again? What if we built one of those games, but fundamentally around what an LLM can do? And so instead of typing directly at a game engine, you're typing and an LLM is like
Hmm.
your helper, your friend in this world that I was imagining you're flying a spaceship around and it's your ship AI. And of course, I'm going to
That's
build
cool.
that primarily with voice, not with typing, right? So I hacked together this little prototype of this sort of multiplayer game. It's voice driven, very simple from a graphics and a gameplay mechanics perspective, but fundamentally around talking to your ship AI and doing stuff together with it, and then other people in the world in their ships. And it turned out that the problems to solve there were exactly the same problems we've just been talking about, like managing very long running context, managing like the ship AI, and then having the ship AI do other stuff by triggering other task agents in the game. And these mechanics were both super fun to think about from an engineering perspective, and also they turned out to be fun just as a game. So some other, colleagues and friends at Daily started hacking on it. One of my colleagues built a beautiful React front end, so we abandoned the TUI. And we've just been experimenting with this open-ended canvas of like, how do you build AI native software? Not how do you use coding agents effectively, which is a whole nother thing, but how do you build software that like is fundamentally AI native, that has LLMs baked into it from the beginning? And everything you do is through interacting with LLMs. And a game is just such a great open-ended, low-risk environment because in a game, if I'm able to prompt engineer the game and sort of get something to happen that's not supposed to happen,
Hmm.
that's actually okay.
Totally.
It's
Yeah.
not okay in an enterprise voice agent that's like
Yeah.
controlling your like bank account, right? So this turned out to be like a really, really fun canvas. And we were like, okay, we got to let other people play this. So we launched it today. You can go to gradient-bang.com. You can play with us in this massively multiplayer online world. And of
So
course, it's
cool.
all open source. So you can see how we built it and you can contribute and you can like, you can refactor it if you want. You can support other LLMs. It's totally, totally a community thing.
I love that. The kid in me is would just be like amazed at what was possible. I remember like, really early games like let's say Knights of the Old Republic or, the Skyrim series or Oblivion. It was amazing when you kind of had like pseudo open world. And now with LLMs, we really can give you a lot more freedom in terms of like what you do and where you take it. And to your point, some things that the game designers didn't expect to happen are sometimes the things that make a game, right?
Yeah.
Like some sort of like exploit or something like that can be really exciting. And I'm sure there's a lot of prompt engineering or prompt injection things people could try to hack the game. I'm curious to dig in a little bit more about what you mentioned, like this idea of the ship AI, and it's the same analogy for like enterprise use cases, like you were saying, sending off tasks to other agents. Would you describe that as like a multi-agent sort of architecture with one orchestrator? What is is there one architecture that you've seen work the best with multi-agent systems, or are there different architectures for different use cases?
So I definitely think there's different architectures for different use cases. In the space of stuff I think about most, the conversational agent orchestrating a bunch of other sub-agents tends to be the right choice, mainly because you always want that conversation loop to be live. So kind of passing everything through the LLM that you're actually talking to is the easiest way to build stuff. Interestingly, that doesn't mean the voice agent, the orchestrator, needs to be the smartest LLM. It just needs to have very clear prompting about how it does that orchestration, because it's often actually starting tasks using reasoning models with pretty high thinking budgets, doing things it couldn't possibly do because it has, no thinking budget ideally, because you want those very, very fast responses. So figuring out that balance, sometimes I call it like a thinking fast and slow architecture, is one of the architecture challenges.
And while it's, sending off these tasks and those tasks are thinking, is it still responding back? Is that
Yeah.
essentially what you're saying by keeping the loop? So do you
Yeah.
normally recommend to say like, hey, I'll look that up. In the meantime, let's talk about this next thing, or how do you facilitate that from a user experience perspective
And
to keep the conversation going?
it's such a great question. In a voice only environment like a telephone call, you definitely want to prompt really well for those responses that tell the person what's going on with the orchestration. So yeah, I'll look that up. That lookup will probably take about 30 seconds, but we can keep talking while my backend system is working, something like that. In the gradient bang context, one of the fun things is that we have this rich UI. So you get these
Mhm.
clues about what the orchestrator is doing from the UI. So there's a whole like task panel where,
That's cool.
there's blinking lights and, scrolling. You can see the thinking process of the subagents, which opens up a whole lot more possibilities. And I actually think, is a super fun canvas for thinking about what the right UIs are for agent orchestration.
Mhm.
I would love to see more experimentation from lots of different people doing lots of different use cases that all sort of rely on sub-agent orchestration in some regard. I think the coding agent harnesses are starting to do it. I love being able to type the down arrow and see, what's going on with the various
Mhm.
like sub processes in Claude Code. But my intuition is that there's so much to do here. I keep thinking that what I really want for a coding agent environment is an iPad. Like an iPad is the perfect device. And what
Mhm.
I want is voice input and like some text, but mostly diagrams out. I want the
Mhm.
I want the coding agent to actually sort of show me data flows and systems architecture dependency stuff. Like that's the level at which I kind of want to work with these coding agents. And we're not there yet. So it feels like so much work to do. But I also want to be able to run 4 or 5 agents at a
Yeah.
time in a coding harness. And I want to be able to monitor them, because if they get a little bit off track, like that's a problem. And that
Yeah.
happens a lot. And I don't know quite how to track that work effectively in a coding agent harness, but we've got some experiments in Gradient Bang that are like indicative of maybe good possibilities.
Yeah, I love the point that there's still a lot to explore when it comes to UX with, especially when you have the ability, like someone's on a browser or on their computer. And like early days when we just saw like every single LM application was a chat interface alone, like why not pull up the product screen next to it? Why not show some graphs or diagrams like you're saying? So I think people are starting to, explore along those lines, which is really exciting. I know we're getting close to time, so just a couple of questions before we wrap up. I want to dig in still, like something that I know that you're experts at PipeCat, and then also with building Gradient Bang, is this like idea of these long running conversations. What is like the one or two big learnings or pitfalls that people fall into if they're trying to build, long running conversations? Is it that compression you're talking about? Is it how do you manage context? What would you advise people to get them started a little quicker if they're trying to build a long running conversation agent?
So almost every voice agent POC starts as just one prompt. Understandably, like that's how we start building stuff
Yeah.
in the AI era. But what you find is that as you try to build some production quality agent that has a specific job to do, and you're really trying to get it to that, 99th percentile conversation success or interaction success metric when it's working with real users, you can't just do one prompt. You start adding stuff to the prompt and you're like, "Oh, it doesn't quite do this thing." And then you add a few more few shot examples and you're like, "Oh, okay, it does that thing really well, but now it doesn't do this other thing as well." And especially if you have something like a use case where there are several steps in the conversation and the agent really needs to do all those steps. So it needs to like authenticate a person, and then it needs to understand sort of where they fit in there in the back end system, and then it needs to answer questions about topic A, and then it needs to ask questions about topic B. That's a very common thing, a sort of conversation design exercise. What you need to do is actually kind of throw away the context pretty often and reload
Mhm.
just the tokens that are most valuable for the LLM at that stage in the conversation.
And do you
Um,
have an engine that's like picking those what's important out, or do you just like cut off? I mean, the most rudimentary thing sounds like you just cut off like older tokens, but there's probably a more advanced way to do it.
yeah, very much so. What you want to do is actually design the conversation as a series of states or a series of phases in a workflow. And
Hmm.
each time you move from, state A to state B, you summarize the history of the conversation so far in a very domain specific way. So you know exactly what state A was, you know exactly what state B was. You have a summarization prompt that tries to compress the conversation and have just the information you need from state A in state B. You change out the tools list, you change out the overall system instruction to go from like emphasizing what state A is needing to do to emphasizing what state B is needing to do. And then you let the conversation go again in this continual multi-turn way until it's time for another state transition. And designing and prompting those multiple states is an art, not a science. These are natural language machines is a whole new way of thinking about stuff, but evals can be written for each state and for the state transitions, and that really helps. And you can also use higher level libraries that make it a little easier to just do the development of those. There's a library that's very widely used in the PipeCat ecosystem called PipeCat Flows. And if you are a programmer, it's sort of natural to think about this as like a state machine, but
Hmm.
it's a state machine that can always go back to any other state or almost all states because human conversation is so meandering. And that has been a huge unlock for a lot of enterprise voice agent use cases, modeling this context engineering as like a series of states and state transitions.
Amazing. That's super insightful. Um, Maybe last question before we wrap up. You mentioned evals earlier on. You were mentioning observability and like how hard it is to, everyone now like knows how to make a pilot or a POC. People are getting agents into production. 2 years ago is like, how do I deploy this? Now you have it there. And still a lot of people are at pretty low volumes. I'm sure you guys work with some of the largest volumes in terms of like agent usage, conversation volume. What are your tips for monitoring agent conversations, how users use products in production? We always like to ask this question because we're an agent analytics platform and we just want to help people learn how to optimize in production and get beyond that like pilot phase. What have you found that works?
Observability matters so much. Like just being able to see where your users are succeeding and failing, and then taking that next step and turning that into evals you can run repeatably, ways just to iterate to get those success metrics up whenever you find that those corner cases. No matter, it's like all software. No matter how much you test yourself with your team, you will not find all the corner
Yeah.
cases. So having in prod some way of collecting data, looking at that data, analyzing that data, and then turning that data into something that you can, hill climb on in the machine learning sense, which might just mean improving the prompting, is so important. I tell everybody, like, whatever else 2026 is like the year of observability and evals.
Mm-hmm. Totally. Love it. Well, Quinn, this has been a fascinating conversation. I want to put one of your many websites up on the screen. It's pipecat.ai, and we'll switch over to the docs page. If you're interested in Pipecat, open source framework that tons of companies and AI builders are using to build their voice agents, please check it out. Anything else you want to add, Quinn, about who should check out Pipecat, where they should follow along with daily or your accounts?
Yeah, I'm easy to find on social media because I find it so fun to talk about this stuff. So, you can search Kwindla on X or LinkedIn and talk to me about this stuff. There's a really active Pipecat Discord if Discord is your thing. And I love seeing what people build. So if you're building, voice agent or real-time AI or just multi-agent system stuff, I would love to see it.
Amazing. And then, since you guys launched it today, I want to also put gradient-bang.com. So if you want to go and try out this exciting new game that the Daily and Pipecat team have built, go check it out. Quinn, thank you for being so generous with all your time and your learnings. You're a true veteran of the space with how early you guys started building and how many different systems that and companies and AI use cases you power. So really appreciate you having you on the pod.
Thank you so much. It's been a really fun conversation, and congrats on what you're doing. I love it.
Thank you. Appreciate it. And to all of you listening in, thanks for tuning in to Built to Ship. If you're building something, go ship it, and we'll see you next time. Bye now.